Hi everybody, hope yesterday went okay. Today we're starting section 2.7 and as you can see it says part 1, so I'm splitting this into two different lessons. The overall topic is parent functions and transformations, and there's kind of a lot to it. If you look here, there's a lot of notes. It's actually not that bad. I'll explain why in a minute. But before I get too far into it, you'll often hear me say when I'm teaching on these video lessons, something like, if you feel like you understand, go ahead and stop the video and get to work. I know if I were a student, I'd want to hear something like that it's okay to stop a half-hour video halfway through if I feel like I understand it. This particular video might be different because when you go through the exercises I'm going to do, they change. So here's one type, there's another type, there's another type, there's another type, there's another type. So this would not be a good assignment to just stop after a couple and get to work. If anything, if you understand the first group, you might fast forward a little bit till you see me talking about the next group. So if you have to save time, you might fast forward a little bit, but I would not just watch a few minutes and then stop. So keep that in mind. Okay, so the topic is parent functions and transformations. A parent function is a type of equation that gives a particular shape. For example, what we've already talked about, y equals a number creates a horizontal line. Y equals x creates a slanted line. Y equals absolute value of x creates a v shape. We've already covered these. These are called parent functions. A transformation is where you take an equation like this and change it in some way by adding a number or subtracting a number, or if I can fit that in there, multiplying by a number. When you start adding, subtracting, multiplying, the shape stays the same, but the position or the orientation of the graph might change. So yesterday, those absolute value graphs, they were all V shapes, but they were in different spots on the graph. Right side up, upside down, skinny, fat, stuff like that. So a parent function is just the basic equation that creates the shape. A transformation is all the extra numbers in there that influence the position. Now today we are going to focus on 4 parent functions. So there's absolute value, quadratic, which is when you have x squared, cubic, which is when you have x to the 3rd power, sometimes called x cubed, and the square root function, that's when you put a square root over x. You can see a quadratic makes this U shape. It's actually called a parabola. You may have heard that before. A cubic creates this shape. It doesn't have a specific name that I know of. I just call it spaghetti. A square root is kind of like half of a parabola turned on its side. We're not doing the cube root one. We could. It's really just this equation sideways, but it's not going to be in this lesson. The greatest integer function we're not doing. It's very interesting. I mean, it makes a staircase, which is really weird to think that a math equation could accomplish that, but it does. We've already killed linear and constant, so we're not revisiting that at all right now. So these 4 equations are our parent functions. We're going to look at the transformations. Now, you should have studied transformations in geometry. There are slides or translations, flips or reflections, and then dilations, which are sometimes called expansions and compressions, or stretches and shrinks. Now, from here all through here, we're covering that tomorrow, okay? I'm going to leave this on the screen, and this is, you can come back to this video and get a capture of this, or actually, I post the notes here. This is something that I want you to have. All of these notes, well, let's say right here, this would be an excellent thing to have copied onto a cheat sheet, something you can refer back to when you have a test or a quiz. Even though we're not covering all of this today, it's all going to be on your paper so that you have access to it. So that's why I included notes that we're not really covering today. It's just something you can have for the future. But for now, we're only going to do translations. Now, if you take a function, f of x is a generic way of writing a function. So instead of writing x cubed, x squared, square root of x, absolute value of x, writing those over and over and over, we just write f of x, and that's supposed to represent a function. When you add a number to the function, it moves the graph up. When you subtract a number from the function, it moves the graph down. When you add a number inside the function, so it's just added to the x, that moves the graph left. And when you subtract a number inside the function, just the x, that moves the graph right. So those 4 things are what we're going to try to learn today. That is the main goal. What happens when you take these 4 parent functions and do these 4 things to them? All right, that's way too much highlighting. Let me undo some. Doggone it. Let me undo some of this so it's not quite so sloppy. I guess that'll be okay. All right. So in the first set of problems, we're actually going to write a sentence or a small phrase. Describe the transformation necessary to transform the graph of f of x, the solved line, into that of g of x, the dashed line. So this blue line right here, what do you do to it to make it look like the green dotted line there? What is happening? Well, to me, it looks like this graph has gone that-a-way. That-a-way would be left. And how far to the left did it go? To me, it looks like it went here to there, which is just one place. So the proper way to explain the transformation is to say that this, if I could spell it right, translates 1 unit to the left. You may use the word slide, not side, slide 1 unit to the left. Or if you're the type who really loves being brief, you can just say 1 unit left. So any one of those answers to me is fine. Let's check the answer key and see exactly how it's phrased by the publisher. Translate left 1 unit. Okay, so there's something that I didn't write, but it means the same thing. Translate, slide, move, it's all good. 1 unit left. Let's look at the next one. This is an absolute value because it's v-shaped. Oh, by the way, that was a cubic function. It doesn't say we need to name that, but I might as well do it just to reinforce some of the concepts. So this is an absolute value function, and to me, if I just focus on one point, it looks like it went up 1, 2, 3 units to get to there. So translate up 3 units. Okay, I'm not going to rewrite this answer 3-4 different ways just to show you the options. So hopefully you understand there's more than one way to phrase your answer. Translate up 3 units. Let's check number 4 and see if that is indeed what it says. And there it is. Translate up 3 units. Number 6. Here we go. This is the square root function. And this one appears to have gone down from there to there, and every corresponding point also moves down. You don't have to look at every single point. You can just focus in on one point and see what happens. This appears to have translated, so translate down 2 units. So this first set of exercises should be pretty easy. You may not love the terminology I'm using, like translate. Usually translate you think of when you go from one language to another. But yeah, it's a math term. If you want to use the word slide, or you can even get very informal and just say the word move. It moves down 2 units. Number 8. This is another cubic function. If I focus on this point right here at the origin, it looks like it's moved to there. 1, 2, 3. So translate, no, that's to the right, isn't it? I'm smart. Right, 1, 2, 3, 3 units. And I'd love to abbreviate. So translate right 3 units. Number 8, does it say that? Yep, translate right 3 units. So that's how you do the first group of problems. Not really doing a lot of math here other than counting. So hopefully you can achieve that. Okay, now for the next set, we do not have graphs, we have equations. Transform the given function f of x as described and write the resulting function as an equation. That sounds very complicated. Here's how you do it. So f of x equals absolute value of x. So this is what we call the parent function. our answer, does it specify? No, I'm going to rewrite our answer as g of x. You're really not supposed to call your answer f of x because f of x is the original equation and our answer is going to be different. So you're supposed to name it something different. We'll see how the answer key does it in just a minute. Anyway, to translate it up 1 unit, I need to take absolute value of x and add 1 to it. Notice the plus 1 is not inside those absolute value bars. If you remember from just a minute ago, or several minutes ago, when you do things inside the function, it moves the graph left or right. If you want to move the graph up or down, you add or subtract numbers outside of the function. So absolute value bars are kind of like parentheses. There's an inside, there's an outside. To move up, you want to add outside. So according to me, that should be the answer. Let's check the answer key and see if I am right. Number 10, right there. They use g of x and everything. Absolute x plus 1, and the plus 1 is outside of those absolute value bars. Let's look at number 12. F of x equals x squared. We want to translate it right 1 unit. So our answer is going to be called g of x. To move a function right or left, we need to, what do we do? Add or subtract? Let me check the notes. To move it right, we need to subtract a number inside the function. Now, x squared isn't like absolute value. It doesn't appear to have an inside or an outside. Actually, it kind of does. So if I were to do plus 1 like this, this would be outside of the function because it's not being affected by the square. It's like separate from it. So we would consider that outside. The inside would look like this. You put x plus 1 in parentheses and then put the square there. So now we introduce our own parentheses to sort of create an inside versus an outside. You put the plus 1 inside the parentheses and then square it. So that should be the answer. Let's check number 12. And there it is. X minus 1 inside parentheses and then squared. Number 14. Translate left 3 units. So g of x equals. To move to the left, let me check my notes, and I encourage you to do this unless you memorize things really easily. Left is where you add a number inside the function. The function here is a square root function. To create an inside for a square root function, you just make the square root bar longer. So if I need to add 3 inside the function, I put a plus 3 under the bar like that. If I put it outside, this would move the graph up 3. If for some reason I subtracted, of course, that would move it down 3. But that's what outside looks like on a square root. But inside is you just make the square root bar longer. And that should be the answer to number 14. Let's take a look. Go too far. There it is. Okay, the next set of problems is basically the same thing, just backwards. You're given f of x and g of x, and then you have to use words to explain what happens. So, number 16, f of x equals x squared, so that's what we called the quadratic. The graph is a U shape, if you recall. That doesn't really matter here. What does plus 3 do to that? Well, let me go back up and check the notes right here. So there are 2 situations where you add a number, right here and right here. Wow, right here doesn't really do much. I am just accidentally deleting a bunch of stuff. Okay, I think all I deleted was that. So this has a plus, this has a plus. Which one of those looks like number 16? So you got to ask yourself, is this plus 3 inside the function, like just happening to the x, or is it outside the function? Keep in mind the function is square, x squared. This is what we would call outside the function. Inside would look like that. So we are adding a number outside the function. This creates a vertical translation. So this goes up 3 units. I guess it probably says translate up 3 units. Let's check number 16 and see. Yep, translate up 3 units. Let's look at the next one. Now this one, in contrast to that one, even though it's also plus 3, this time it's inside those absolute value bars. So when you add a number inside the function, let's check the notes again, that moves the graph to the left. So add inside the function moves it left. Wow, I gotta stop scrolling up and down. So translate left 3 units. And I gotta scroll down to check number 18. Translate left 3 units. Okay, I'm going to go ahead and look at the answer to number 20 so I don't have to move up and down as much. Number 20 should be right 2 units. Let's do it and see. Why is it right 2 units? Okay, so why is it 2? Because there's a 2 there. Why is it right? Because there's minus, and it is inside the function, not outside. Remember, outside would be out here. That would move the graph up and down. Inside moves it left and right, so this is translate right 2 units. Okay, so we're looking at adding and subtracting numbers in equations to see what it does to the graph, and it either moves them left, right, up, down, and the point you're really trying to learn is, which is which. So we've got these 4 scenarios, 1, 2, 3, 4, of adding or subtracting either outside or inside the function. Let's look at the next group of problems. Oh, you know what? We've done some graphing on Desmos. If you are looking at a problem like number 16, or maybe obviously 15, I would like it if you could do it the same way that I'm doing it. You maybe check your notes, use your head, write it out. But if you absolutely have to, you can graph this on Desmos, graph this on Desmos, then you'll have a picture to look at, and it'll be a lot more like these problems, where you can just see, is the graph up, down, left, or right? So keep that in mind. There's a way you can sort of help yourself. Okay, identify the parent function f of x and write an equation for the given function. So, do you remember the name of the function that creates a V shape? You should have said absolute value, and you are correct. But I'm not going to write the word absolute value. Nope, that's not the answer we're looking for. The answer we're looking for is f of x equals absolute value of x. Got it? So that is this part of the instructions. The second part of the instructions, write an equation for the given function. Well, if you recall, a regular absolute value of x kind of looks like this. I'll do a dotted line to sort of indicate that it's just a thought process here. It's not actually part of our answer. The graph that's given is actually down 1, 2 units from there. So my answer, I'll call g of x, is absolute value of x minus 2, because the graph that's given is 2 units below where an absolute value normally is. So these are the 2 things we need to put in our answer, the parent function and then the function that's actually graphed in the problem. Let's check number 22 and see if I did that right. There it is. Well, they even labeled it. Parent function, absolute value, and then the answer, absolute value of x minus 2. They even used g of x. Okay, number 24. Which graph is this? If you got a good memory, you probably said square root. If you don't have a good memory, you should have scrolled up. Well, I mean, you can't because I'm the one with doing the video, but you can scroll up or you can look at your paper if you print this out, whatever. There it is right there. It's the square root function. F of x equals square root of x. So the parent function here is f of x equals square root of x. Now keep in mind that parent function normally starts at the origin and goes like this. Our function has shifted 2 units to the right. So the equation of what's given right here in the problem has to be a square root function, but it has to be shifted 2 units to the right. Now you can check your notes, but I'm going to tell you because I remember. To shift 2 units to the right, you need to put a -2 inside the function. Remember, the inside function on a square root, you just make the bar longer to create sort of an inside versus an outside. So that should be the answer to number 24. Where the heck am I? Right there. Check and check. Let's look at 26. This function, the one that looks like, okay, so if you took a handful of spaghetti and threw it at the floor or threw it at the wall and it stuck, guaranteed one of them is going to look kind of like that. So this I call the spaghetti shape. It's actually called a cubic function. F of x equals x cubed. And a normal cubic function, let's change colors for no particular reason. A normal cubic function looks kind of like this. The problem that's given appears to be shifted up 1, 2, 3. So the function that's given we'll call g of x. It's a cubic function, x cubed, but shifted up 3 units. Hold on, that 3 does not look like a 3. So x cubed plus 3 is a vertical shift up 3 units. Let's check number 26 and see if I'm correct. Check and check. 28. If this is too repetitive for you, I'm sorry. It's just, repeated practice sometimes the way to go when you're doing math. Okay, this is the U shape. Why did I change colors? Don't want to change colors yet. The parent function of the U shape is called a parabola. The function is a quadratic. It is x squared. The normal quadratic, this is where I want to change colors, starts at the origin and makes a U shape. This function is 1, 2 units left of the origin. So left or right, let me write my answer, g of x equals, left or right, you have to do something inside the function. So I put parentheses down on a square. Left 2 units is actually plus 2. So that should be the answer for number 28. And there it is. Check and check. All right, we are almost done. The last set of problems, sketch the graph of each function. Now I'm going to do these in 2 parts. Part 1, I'm going to do the parent function as a dotted line, and it doesn't really count. It's not really the answer. X squared is the parent function. That is this parabolic or parabola shape at the origin. -3 outside of the function shifts this down 1, 2, 3 units right there. I'll do my actual answer in blue. So we should have a parabola that looks kind of like that. Okay, it's a little wavery. My hand isn't that steady, but hopefully it's good enough to call it correct. And there it is. Now the answer key, they count 1, 2, 3. So we're good. Yeah, that's right. Yep, okay. Number 32, a square root function. Again, I'll do this parent function in red. You don't have to do this, but to me it helps. The parent function of a square root kind of looks like that. +2 inside the square root bar moves it left 2 units right there. So let me do this in blue. I need to make an arc that looks kind of like that. Again, the blue is the only actual answer, number 32, and there it is. Okay, that is the whole lesson. For sure, contact me if you have questions. I can set up one-on-one Google Meets with people and talk you through this. I can help you out. When we do our Google Meet, I can help you there. Or if you just email me or use comments to ask a question, I can type up an answer. So don't be afraid to do that. Again, this stuff here we are covering tomorrow, and it won't be, there might be a short like 1-minute video, 2-minute video, but you're going to do a different type of activity, hopefully to learn this, and then a small assignment. All right, I'm going to stop there. Hope to talk